Hello everyone. Today we are talking about the sun. What is it? How it makes energy? How it formed? And how will it die? First, let's talk about what it is. It's the yellow dwarf star of the solar system that orbits around the center of the Milky Way. It's 93 million miles from Earth, which is so far, and is also one astronomical unit. It it makes up around 99.8% of all mass in our solar system. It's huge compared to us, but it's not even one of the biggest stars in our galaxy. However, it is bigger than the most common star in our galaxy, the red dwarf. Um, it's so it would take around 332,900 Earths to match the mass of the sun, and around 1.3 million Earths can fit inside the sun. It affects our climate, our tides, and creates northern lights, also known as auroras. It's 91% hydrogen and 8.9% helium by atoms, but by mass is actually only 70.6% hydrogen and 24% helium by mass about. So the sun's made out of layers just like Earth is. It starts in the core. So there's the core, the radiative zone, the convective zone, the photosphere, the chromosphere, which is the lower atmosphere, and the corona, which is the outer atmosphere. It formed. So how did it form? It formed from a rotating cloud of gas and dust called a solar nebula. Most scientists estimate around 4.5 billion years ago. When the nebula collapsed under the force of its own gravity, the nebula flattened into a disk shape. The center of the disk made the sun, and the rest of it made all the rest of the planets and everything else that's in our solar system. So, how does it make so much energy, right? It starts with a core, which only makes up about 20-25% of the radius of the sun, and has a temperature of 27 million degrees Fahrenheit or 15 million degrees Celsius. That's really hot. This is hot enough for nuclear fusion to occur. Nuclear fusion causes hydrogen atoms to fuse together and make helium. Most of the sun's energy production happens in the core, and by about 30% of radius, or just outside the core, fusion stops almost entirely. Next is the radiative zone. This area uses thermal radiation to move the heat upwards from the core. It's around 12.5 million degrees Fahrenheit or 6.9 million degrees Celsius. After that, we have the convective zone. Here, it's only around 9,800 degrees Fahrenheit or 5,400 degrees Celsius, which is still really hot, but it's not as hot as the core. Not even close. Since it is cooler, the heat travels in a different way here. It uses convection. So the particles heat up at the bottom of this part, and then they raise up through the layers until they cool back off and drop back down. It's kind of like a conveyor belt. So after that, we have the photosphere. This is a visible layer of the sun. This is also where you get sunspots. The temperature ranges from about 7,500 to 10,000 degrees Fahrenheit or 4,200 to 5,700 degrees Celsius. It ranges due to the fact that the upper part is quite a bit cooler than the lower part of this layer. This is where the heat and light made by the sun radiates into space. So that's how it makes energy. So before I get to death, I have a fun little fact for you guys. 5 out of 6 people find Russian roulette completely harmless. Don't try it, but that's just, 5 out of 6. Alright, just what the little tidbit in. Alright, so how will our sun die? Many people believe it will supernova, but that's simply not true. Our sun isn't big enough to supernova, so what will happen? Well, we know there's no need to panic, as we most likely have another 5 billion years before it starts to enter the dying stages of its life cycle. When it does start entering stages, the first stage will be it'll balloon into a red giant, which will it will expand into a red giant. which will solve Mercury, possibly Venus, but most likely just Mercury. Um, it will eventually start running out of hydrogen to fuse after about a million years of that. Um, and so, and it won't be hot enough to ignite carbon in its core. So it will succumb to gravity since it's already basically trying to fight gravity, and which will cause a huge release of energy that will make the envelope of the sun expand. The sun will become even bigger than before when it was a red giant. Our sun will then be about the size of Earth's orbit. So at that point, it will completely swallow everything. It'll swallow all the way to Earth, basically. So that's awesome. That's interesting. So the sun is not stable in that state, like at all, really, and it'll keep losing mass until it eventually just kind of throws the outer part of itself into space. So after that, it will collapse and become a white dwarf. Typical white dwarf has around the same mass as the sun, but it's only about the size of Earth. So would make it one of the most densely packed matter combination matter in the universe. It will remain as that until it completely runs out of fuel, making it a black dwarf, which is just a dead star at that point. So let's go over what we learned this episode. We went over the basics of the sun, how it formed, how it gets energy, what each layer does, and how it'll end its life cycle. Thank you all for watching. If you liked, hit that like button and subscribe for more content. Tell me down below which subject you would like me to talk about next, as well as always, there's a question down there. Today's question is just what's something fascinating, something you thought was interesting that you learned in this video. Hope you guys have a great day or night, whatever it is.